We'd like to invite Thomas and CREAL3D to the stage.
So hello, I am Thomas, and I would like to introduce you CREAL3D. Now, okay, so when we look at how we consume information, we have seen several step changes over the past few decades, from big computers to the small digital companions that almost all of us carry in our pockets. However, the smartphone market has already peaked in 2017, and a lot of manufacturers are looking what would be the next big thing, what would be the next device that would make our lives even easier and better. And augmented and virtual reality devices are one candidate. If they were really to take off, the potential to improve human life is enormous, and a lot of smart people have trying to estimate how big market that could be. However, for you familiar with the market, so far it has not been taking off as all these smart people were expecting. But why? Well, one reason is that the technology is so far not ready for the task, that the gadgets and the headsets you can buy today are something like a smartphone before the iPhone. It's a nice piece of technology, but it has not yet matured enough to be a consumer device. But again, why is that? Have you tried one? Did you have a pleasant experience with it? Maybe you tried and maybe your experience was just not something you would want to repeat. And why was that? Well, there is actually a technological explanation. The technology that the current headsets are using to produce the image is fundamentally wrong. What happens is that you are looking at two screens that are optically in the infinity. But if you are trying to focus on something close that's in front of you, your two eyes are seeing that there is something close, that they are looking together, that they verge together. So the brain tells them, you should focus on something close. But the eye responds back, it's not the case. We are still focusing somewhere to the infinity. And the brain is telling them, that's not right. We probably have something poisonous in the stomach, and we should better get rid of that from the stomach. And that's one of the reasons why you then sometimes not feel very well after using the device. So this leads to this unnatural, unpleasant and unhealthy experience. It's really, there is divergence accommodation conflict between how your eyes focus and how close you think that the item is using the two eyes. And now we have actually invented a cheap way how to produce a light field, which is a term describing a display that is providing optically correct image. Something that looks like hologram, that has proper optical depth. And this allows to build a headset that feels natural, that is pleasant to use, and that's healthy to use. Now, what the light field is, probably best would be to show you an example so that you can see it through your eyes. So what I'm going to show now are images that were shot looking into our prototype. Now you see an image, there is a nice creature looking at you, and the DSLR camera we have used to take the image was focusing on the creature. Now, without any change of the image, the projector was not aware of the camera, there was no feedback. The camera refocused on the leaves behind the creature, and you see that suddenly the leaves became sharp, the creature became blurry. I will show it again. And again, the image projected by a projector is the same, identical, unchanged. It's the same thing as you were focusing on me or on the podium here. It's not aware of where you are focusing, and yet it gets sharp when you focus on it, and it gets blurred when you focus on your finger. And that's the same way. We project the light in a way that it has all the optical information, that the depth is there, and the devices perceiving it behave just like they were perceiving a real world. And how we do it? We have actually came out with pretty unique hardware solution that takes existing mass market components and puts them together in a different way. We have added some proprietary light source, optics and rendering algorithms. The great thing is, it has no moving parts, and because it's made from components that are already manufacturable, we believe that when making at scales, the bill of materials would be below $100. So it can be made cheaply, it's a piece of hardware, so it can be patented. We have spent a lot of effort on patenting it. And it should be very reliable and robust. What is also important thing to say, it's prescription glasses compatible. Now, so imagine if such technology were incorporated into a device. I have sent a sample that you can try to look at it. What all the opportunities would open for the applications. For example, it would allow you to do proper remote presence or remote assistance, where people are collaborating on something that they see together, even though each of them might be on the different place in the different country. It would allow for high-resolution head-up displays that would be providing information that would be optically tied to the objects that is relevant for. It would be a great tool for AR, VR training because you would have the same experience as if you were looking on the real thing. But maybe even larger potential is in visualizing three-dimensional data, because today we actually have lots of three-dimensional data. There are some cool data from NASA about the weather, but actually we have also plenty of 3D data in healthcare. We build a lot of 3D models on the body, but how do we look at them? We actually look at them on the flat screen. We are doing a lot of work on designing cars parts that are naturally three-dimensional, but again, we are looking at them on the flat screen. We are looking on the products. If you go on Amazon or on some other site and you would want to preview your next handbag, are you really sure that the best preview for a handbag is two-dimensional pictures? Is that the way how you get the most information about that object? Is it better than if you were seeing it in front of you, just like if it was really there? Now we really have plenty of digital three-dimensional data, and we flatten them to put them on flat screens. So that's the place where actually showing 3D data on a display that's properly three-dimensional is really something that would be natural and the way to go. Now, how we approach such market. Because we have something as unique, we have figured out that rather than trying to build the device ourselves, we will be offering the technology and the components to someone who actually already knows how to build AR and VR devices. So this year, we already plan to put some evaluation kits on the market so that the manufacturers can play with this technology no one has ever shown before. Then we plan that in 2020, some of those who will like it will do some integration deals and pay us to help them to put our technology into their devices, with the first probably niche devices hitting the consumer market in 2021, and this is when our revenues will start pouring in the big scale. To look at the steps more in detail, so the first product would be more like tabletop evaluation kits, and the unique selling point there is clear. You cannot buy it from anyone else. If you want properly visual display that would fit into a headset, there is one company that sells it, and that's CREAL3D. But in 2020, we plan to shrink the technology about 3 times so that its form factor would be compatible with a headset like that, something that you have seen in your eyes, and something that we will see would be product ready and to be put into some consumer device. And ultimately, it's physically possible to actually shrink our technology into something as small as that, something that would be fashion compatible with your current glasses that you might be wearing, except that unlike your current glasses, these glasses would replace the screen of your smartphone, allowing you to see 3-dimensional objects blending with the world around you, potentially replacing not just the screen of your smartphone, but almost any other screen you are using, because that might be the new way how you consume digital information, properly merged with the world that is around you, using a device that is almost unnoticeable on your head, just like today you might forget that you are actually wearing glasses. Now about the traction, we are already in contact and we have spent significant face time. When I talk significant face time, I talk about several face-to-face meetings that were taking hours or more and that were repeated from the executives in major hardware manufacturing corporates. We do have affirmations of people who want to buy our evaluation kits, both from the scouts and R&D labs of these corporates and from academia. We have already completed one NRE with a corporate, and we are negotiating 2 more NREs already. We have also shown the technology to some opinion makers and leaders. Karl Guttag is a very knowledgeable guy in the display technology. He has 200 patents to his name, and he likes to debunk marketing myth, and he was actually pretty impressed by what we have shown him. And we have also shown it to some expert public on the CES 2019. And again, we have seen the surprises confirming that this is actually something that people has never seen before. Now, when I said never seen before, it's really that we were able to find some cute way that actually offers unlimited, almost unlimited depth resolution, very good spatial resolution, providing very nice crisp images, and yet it fits into nice small form factor and can be made for cheap. It's actually much more efficient than a lot of the technologies that other corporates might be trying to use that might be more technologically advanced, might be playing with more advanced hardware like waveguides, laser steering, really high-tech stuff that unfortunately has one disadvantage. It's pretty expensive. You know, now if you would want to buy, for example, Magic Leap's headsets, it's $2,200, and we are not sure whether they are making money on it. We think that they might be selling it at a cost. So compared to this, our technology that you could be making for $100. It's really a unique solution that seems to be better than anything else that's currently on the market or what we know about. And how are we going to make it? Let me introduce our team. The father of the idea and the principal inventor is other Thomas Sluka. He has worked as a researcher at CERN. He has worked as a researcher at EPFL, which is something like the European MIT. And he has worked in many different disciplines, in optics, in electronics, in materials. And I believe that's because of this multidisciplinary nature, he was able to see something different than people who are plainly focused on just one type of technology have not noticed, and this is what has allowed him to come up with the technology. He's joined with Alexander, who had already done a hardware startup in Switzerland and has experienced how to do it. He was joined by me. I was a business consultant and vice chairman of non-profit, so I'm bringing some of the business experience. Now we have Robert here in Silicon Valley. He is a hustler and he knows people, which is always important. And we are also joined by Lucio, which is again someone who had a startup that was acquired by Intel. He went all the way from ideation to industrialization, so we have a lot of relevant experience, and we are supported by engineers that have a lot of knowledge from great universities in Europe. And how are we going to do it? What we need? We are a hardware startup, and hardware is hard, so we will still need some money to actually perfect the technology and bring it to the first type of the product that can be introduced. But we believe that we will break even in late 2022, and then after that, because that will be a technology that everyone might be interested to employ and customize, at that point big money will start pouring in. But to get to that big money, we have opened an A round and we are raising 5 million to close in the Q4 of this year so that we can get the technology to the minimum viable product that we can ship to customers and get paid for. With that, I would like to thank you for your attention, and I am here for your questions.
Thank you, Thomas. Questions from the judges?
Please.
At the table, will you be able to demonstrate looking at 3D data?
Sorry, can you repeat?
Will you show us a demonstration of looking at 3D data?
I am not able to show you demonstration today because I do not have working prototype. I have just the mock-up.
Okay, thank you.
If you were to meet in October, I would be very happy to do that.
Okay.
Don't worry. I'm looking forward even for hard questions.
It's something that I think all of us need a little time to prepare our questions. I bet some other people are thinking. But just as a comment, I really loved that you actually showed your goal for the presentation of raising money. We got to see some financial projections, and you've had a very crystal clear roadmap on what you want to deliver each year for the next 6 or 7 years. And that's just so important, especially in a hardware startup where you're going to be putting your heads down and be developing for years. And I really enjoyed the concreteness of your plan, and you also weren't afraid to show what the competitors are doing in a very clear way.
Thank you. Thank you.
I love the form factor, and I have some questions about that. So when I play with my Magic Leap at home, it has the pack that you put on your belt, and it's pretty big, and it uses a lot of power. So my main questions around the form factor here is, so is this the entire device right here? Where's the battery? Where's the CPU? What's the battery life? Can you talk about those?
Great question, and I thank you very much for that. It is true that this device is only the thing to project images to your eyes. The answer is simple. Your face and your head is very sensitive to weight, and it does not make sense to put anything but the most essential parts to your face. And at least in 2020, we will definitely need a cable here and plug it to something like your smartphone or customized device to feed it with the data. But since our rendering should not take much more effort than rendering a flat image, we believe that something like a smartphone would be powering it. And because our unit is actually very light, efficient, we should not have significant power consumption. So we are convinced that something like today's smartphone connected to the device at first using wire, then maybe some more niftier technology would be needed to feed it.
I got one for you. I've seen the patent over here. I've seen the patents that Apple's working on for potentially Apple glasses. Have you seen that? Are you tracking that? And do you see that as a potential competitor?
We are actually very happy that Apple is working on something like that, because so far the patents we saw, we tried to do patent search, but we are really just 8 people, so we cannot track everything all the time. But so far, to our knowledge, they are working on something different, and we are confident that we have a technology that at some point they will really like. But what we like is that Apple is known to break open new device classes, that they really make a market success out of that. And of course, that would drive a lot of interest in actually how it can be improved with our technology.
So right here. So
Please.
as a father of 2 boys who are active gamers and active in VR, AR systems, and seeing that emerging technology and its potential through all industries, including in space exploration and scientific discovery, I just wonder where this fits into that space and what you think it's going to do to enable kind of us with our science and exploration mission. So it wasn't clear enough in your presentation to me.
Well, this is a very broad question. In general, we really believe that we now are surrounded with a lot of 3-dimensional data that we cannot consume properly. And for example, if you were trying to remotely control a remote arm to grab a screwdriver or something with the today's display technology, it would be a very, very challenging task. Because your perception of this space would just not be correct.
So you're implying that we could use this technology, possibly built into some of our vision systems for some remote manipulation of the environment we're in or the systems? So it's not a user uses it, but the technology is transferable for us to use in optics-based systems.
Yes, because something like light field cameras already exist. These you can buy, but something to actually display light field data does not exist, and this is what we are bringing. That we have something like general purpose screen, and this would be one of the use where it would be clearly more beneficial than existing technology.
Okay.
So I know your job is to evangelize AR as much as possible, but there's probably some areas where it's overblown, as with any new technology. In your opinion, where is AR misapplied?
Well, this is again great question. Now I believe that it needs to be split to two parts, because definitely in some areas AR is now overblown today because the promises that were made really could not be delivered without a technology like we have, or some similar technology that provides the optical depth. Without that, the devices would always be not very pleasant to use and your body would be confused by them. It would be unhealthy and unnatural. So basically in that, there have been a lot of promises that, for example, cannot really be satisfied with anything you can buy. But I am very confident that once it takes off, it would really be something that would replace and change the way how we consume information. Because now we consume all the digital information from the flat screen. But it's really like at some point, if you wanted to go from East Coast to West Coast, the only way would be to walk or ride a horse for several months. And it's not because that was the best way, it's because that was the only way before the railways were built or airplanes invented. So now we consume everything from a flat screen because that's the only way how we can display it. But once we will be able to display fully three-dimensional information, I'm very confident that a lot of things will change a lot.
So then besides remote manipulation, which application of AR do you think has the biggest commercial potential in the next 10 years?
In the next 10 years? Well, I believe in the end, it would be the general purpose device that would replace most of the screens that we have. Before we get there, there might be some niches where the first applications would be closer to approach. And then again, this might be something where you really want to deal with data. For example, we have been looking into people examining molecules for medical research, where perceiving them in 3D is really very helpful, because so far humans are able to perceive them and still see how they will snap together much better than computers are. But for that, you really need to see them properly three-dimensional, not just the image, which now you can do if you print them. So now there have been a lot of experimentations going on in there. This might be one of the areas, and I see that there might be many other niches like that where the demand would be highest and the product would not need to be perfectly consumer-made sure to already bring significant return on the investment.
Thank you.
When are you going to have your prototype ready for investors to have a look at and try? And
we have now one prototype. Unfortunately, it does not travel well, so I have not been able to bring it. But as I had, we are planning to ship them in late 2019. So by the end of the summer, we should have units to examine. And by autumn or late autumn, we should have many units to be able to ship to you so that you can see.
Thank you, Thomas.
Thank you.